Circuit Playground is a really fun, really easy to use microcontroller that's a great way to add sensors and interactivity to your project without a whole lot of fuss and soldering. It's got a built-in motion sensor, a sound sensor, a light sensor, and a temperature sensor, as well as a built-in speaker and 10 neopixels, ready to use right out of the box. I'm just starting to explore the fun things that this board can do. Today we're going to focus on the motion sensor. I was inspired by Becky Stern's Sparkle Skirt tutorial, which uses a Flora and an LSM303 motion sensor to make the lights in a skirt twinkle when you move. This is a really popular guide, and I have a lot of friends who really want a sparkle skirt, but the soldering is a little intimidating, and using a separate sensor and a board can be difficult. Using the Circuit Playground makes this project a lot easier. Before you start, you'll need to install some software on your computer. We'll be using the Arduino IDE with the Circuit Playground library. Installation is covered in the Introducing Circuit Playground guide. See the links in the comments. You'll need to install Arduino, then the Adafruit board support, and then the Circuit Playground library. Once your software is installed, come on back. I'll wait. Once you've got everything installed and your computer can talk to the Circuit Playground, it's time to start playing with the sensor. Plug your Circuit Playground into your computer and select the board in the Tools menu. Then select Circuit Playground as the port. Now, go find the Circuit Playground examples in the Library Examples menu. Open the Hello Accelerometer example code. Upload it to the board. Now, open your serial monitor in Arduino. The serial monitor gives you feedback from the board so you can test your code at a really basic level and make sure everything's working. If all is well, you should see some numbers scrolling by in this window. You'll see values for X, Y, and Z. These represent the 3 different directions this board can move. Keeping the Circuit Playground plugged in, pick it up and move it around a bit and watch and see how the numbers change. This is still kind of a lot of info to process, so let's simplify it. First, think about how the board will be mounted in your project. I plan on sewing it into a pocket in my skirt with a USB port facing upward and the board in a vertical orientation, so that's how I'm going to hold it when I play with the sensor. Let's simplify even more. Go into your code window and comment out all the serial commands that talk about Y and Z. We'll just focus on X for now. While you're in there, change X's second serial print to a serial print line command. This will make a new line for each value in the serial monitor so it's easier to read. Upload the code again. Take another look at your serial monitor. You'll see just one reading for X appear each second. Play around with moving the Circuit Playground through space again and watch what happens with the value on the screen. Try moving the board in all 3 dimensions and see which one changes X the most consistently. With the board oriented the way I want it in my project, it looks like X changes the most dramatically when I turn the board clockwise or counterclockwise. Go back to your code and uncomment only the Y lines and upload again. Then get a feel for which axis of movement the Y direction controls. Looks like it's related to the board twisting left to right. Try once more with Z. Z appears to control the back and forth motion. So, the data for X will measure my side-to-side motion, like when I do cartwheels. Y will measure whether I'm spinning around in circles, and Z will be able to tell me if I'm doing forward bends or back bends. I want to use a combination of all three, so the lights come on whenever I move any which way. Rather than starting from scratch and having to do my own math, I've borrowed some code from the Sparkle Skirt guide and modified it to work with this circuit playground. Upload this code to your circuit playground and watch the serial monitor as you move the board around. The word twinkle will appear whenever the board moves far enough. Change the move threshold number to make it more or less sensitive. Lastly, let's get out of the serial monitor and into the real world. We can easily make one of the neopixels on the board twinkle whenever the move threshold is reached. Open another example sketch, Hello Neopixels. We'll grab the code for pixel 0 and copy it into our twinkle loop. We'll also add the clear pixels line to the beginning of our loop function so the light goes back off again. And we'll shorten our delay so that everything happens in real time. Upload the code again and move your circuit playground around to make the light twinkle. The applications for this are endless with a little creativity. Check the Adafruit Learning Center for the next steps and more code samples to get your project twinkling.